And yeah, going back to AMD, who closed a deal to acquiring FPGA developer and producer Xilinx. For everyone who is not familiar with the term FPGA, FPGA stands for functional programmable grid array. So you have a chip that you can basically code the behavior into it on demand. So despite a so-called ASIC, which is basically a specialized chip that is made for a specific purpose, you basically, every one of you has an ASIC in your phone. Basically, all smartphone chips today have ASIC components. For example, for AI, for image processing, and so on and so forth. Those functions are basically enhanced with ASICs who are optimized to perform particular tasks. And what an FPGA allows you to do is to basically not have a hard-coded or physically encoded circuit for a particular task, but you can basically tell the FPGA what its purpose is in a particular moment when you feed before you start feeding it data to process. And as a coprocessor for CPUs and GPUs, that is very, very interesting, especially when you see basically systems making use of special circuits like today with the phone ASICs, and even on CPUs like Apple's or not CPUs, let's call it SoCs, so system on chips, like Apple's M series processors, where they're combining not only compute units for general compute, but also units for AI. That's for in Apple's case is called Neural Engine. In NVIDIA's case, it's called tensor cores, and they also have circuits for image processing, and even now with the Pro and Pro Max and Ultra models, also for video encoding and decoding. So there is a lot of specialized circuits in modern chips, and basically combining the general compute of a CPU or a GPU with something that can do more specialized tasks, so with a higher efficiency and taking load of the general purpose compute unit, that is a huge thing, especially when you think about case that came right into my mind in AMD's case would be AMD does not have ray tracing circuits right now. So AMD is using their regular compute units on the GPUs in order for calculating the ray tracing, which works, but not as efficient as NVIDIA's RT cores. And if you now think about it, not doing specialized RT cores on their GPUs, but perhaps with the upcoming GPU generations and CPU generations adding FPGAs, depending on what you do and what you configure, a accompanying FPGA could get instruction set for ray tracing, or even like something like DLSS. FSR is AMD's competitor for that, which is currently not AI based. So depending on how you do it, you have much more options and could use an FPGA to load off that particular workload from the general compute unit. And the big thing in my mind for that is, when you bought, for example, a RTX 2000s card from NVIDIA, you are locked to the RT cores and tensor cores that are on your particular card. That means if there are improvements to the algorithms that are used, for example, in the updated cores that are now on the 3000 series from NVIDIA, you're not participating in those improvements. You cannot, physically not. What an FPGA instead allows you is you get an update delivered to your system, perhaps as part of a driver update, that tells the FPGA, hey, here is now my new ray tracing algorithm 25.0 or something. And suddenly, without changing the hardware, you have all the improvements of the new algorithm. And that could be huge. And if you want to learn more about how FPGAs work and what the possibilities are, I linked in the show notes a video by YouTuber Cortex, and he's discussing all of that. And the weird thing is, in his discussions and comparing the solutions that you can implement, for some reason he is focusing on Intel's solutions that are using specialized circuits, and he's not even talking about what Apple is doing. And for me, Apple is currently the prime example what utilizing the specialized circuits on their chips, because Apple is a prime example because of the tight software and hardware integration. And also, he's only talking about pairing the FPGA with the CPU. But I don't see a reason why you couldn't pair a FPGA with a CPU and with a GPU, so that you can leverage an FPGA on the GPU, no matter if you have a CPU with an FPGA installed or not. And those chiplet designs, these chiplet interconnects, are an important part here, because in theory, AMD/Xilinx can also supply these FPGA modules to other companies for integrating them into their CPUs and GPUs. So it will be interesting to see what AMD comes up with. And according to the reports, they are planning on releasing first products with Xilinx FPGAs integrated already in 2023. So it could be that we are seeing probably first enterprise products at the end of the year or early next year. And then it's not long until we see it in the consumer space. Or even AMD says, okay, we do it in the consumer space first, because they are then getting an advantage in regards to functionality compared to NVIDIA. And of course, Intel is also now getting into the GPU space. So it will be interesting to see what they will be doing there.